In this video, we want to look at section 2.7 where we'll be combining functions. We have several different ways to do that, so I want to do two different examples. The first one is find f plus g, f minus g, f times g, and f divided by g, and their domains when f of x is equal to 1 over x and g of x is equal to x squared minus 4. To do this, we first want to know what the domains of each of these functions are individually. So the domain of 1 over x is equal to, well, if we have the function 1 over x, we're allowed to have everything except for 0. So this is the domain negative infinity to 0 union with 0 to infinity. Another way to write this is all real numbers are minus the number 0. And we put this in set notation here. And a backslash is our notation for minus when we're talking about subtraction of sets. So we will also want to know the domain of g of x. So our domain of square root of x squared minus 4. Well, the domain here is all values that make the square root of x squared minus 4 possible to compute. And what does that mean? That means x squared minus 4 needs to be 0 or positive. So x squared minus 4 needs to be equal or greater than 0. Well, x squared minus 4 factors into x plus 2 times x minus 2. This needs to be equal or greater than 0. Again, if we do a little trick that we've done before here, negative 2, positive 2, those are zeros. Plug in something to the left of negative 2, so suppose negative 3. Plug in negative 3, we get a negative times a negative. That is a positive, so this is equal or greater than 0. If we plug in something between negative 2 and 2, so suppose 0, we get a positive, we get a negative. Positive times a negative is a negative. Plug in something bigger than 2, so suppose 3, we get a positive times a positive. Oh, that is positive. What does this tell us? This tells us our domain, then, is the interval from negative infinity to negative 2, inclusive, because a negative 2 is allowed, right? That would make this function equal to 0, which is allowed here. Union 2, again, inclusive, to infinity. So those are our domains for each individual function. So now let's actually calculate the problem. What do we want? Well, we want f plus g of x. Well, this is the same as f of x plus g of x. F of x was 1 over x. G of x was the square root of x squared minus 4. And so this is our f plus g of x. If we want to, we can combine those fractions and make it 1 over x plus, to add fractions here, we need an x in the denominator. So this would be x times square root of x squared minus 4 all over x, which is the same as 1 plus x times square root of x squared minus 4 all over x. We don't need to do that here. I would be okay with this answer, but you should make sure that what WebAssign wants. So as you practice through the homework, you can check what WebAssign prefers as the appropriate way to enter this answer. The other thing we want to do, besides f plus g of x, is to calculate its domain. Well, the domain of f plus g of x is the intersection of the domains of those two individual functions. So it's the intersection of all real numbers except 0, and these two intervals. Well, the intersection of those is just this domain here. So, what is the domain of f plus g? Well, that is just negative infinity to negative 2, union 2 to infinity. Here's the domain, and here is f plus g. We're going to continue on and do f minus g now. This is f of x minus g of x. This is 1 over x minus square root of x squared minus 4. And again, the domain is just the intersection. Oops. That would be a minus g, sorry. The domain of f minus g is just the intersection of the domains of the function f and g. So again, this will be negative infinity to negative 2, union 2 to infinity. F times g of x is just f of x times g of x, which is 1 over x times square root of x squared minus 4. We can write this more simply as the square root of x squared minus 4 all over x. And again, the domain will be the intersection of the domain of f and g. We have one more here, and that is f divided by g of x. Well, this is the same as f of x divided by g of x. And f of x is 1 over x, and we want to divide by g of x, which is the square root of x squared minus 4. So this is the same as 1 over x times the square root of x squared minus 4. Here, the domain is the intersection of the two, but also we can't allow g of x to be 0, because if this is 0, then we have a value over 0. So now we don't want to allow that g of x to be 0. Well, when is g of x equal to 0? That is equal to 0 when x is plus or minus 2. So we now have to take those values outside of our domain, or out of our domain. So our domain for f divided by g is negative infinity to negative 2, but now not inclusive. So we write a parentheses instead of a square bracket, and then 2 to infinity. And this is our domain of f divided by g. All right. We have a few more examples from this section. So I want to continue on. And we're going to combine functions in a different way. And this is going to be composite functions. What is a composite function? A composite function, it happens when you put one function inside another function. So for this problem, I want to find f composed with g and g composed with f, and their domains when f of x is x squared plus 2 and g of x is the square root of x. So to do this, f composed with g of x can be written as f of g of x. And if we use this notation, this represents exactly what we want to do. We want to plug in g of x into the function f. So let's do that. So our function f was x squared plus 2. So we have something squared plus 2, but what goes in there? What goes in there is g of x. Well, what was g of x? G of x is the square root of x. So this is the square root of x squared plus 2. And this is equal to square root of x squared is just x plus 2. Now, this is a little tricky when we ask what the domain is, because I don't want to look at this function or this expression for the domain. Really, our expression was the square root of x squared plus 2. Well, what are we allowed to plug into here? Well, if we have negative values, we cannot find this expression. We can't plug in a negative value here. If I had -3, well, we can't take the square root to then square it. So we still are not allowed negative values. So really we want to look at this way of expressing our equation, or our function. And when we look at that, we notice that the domain of f composed with g is equal to, and we can plug in everything as long as x is equal or greater than 0. All right, I'm going to do one more here, and that is g compose f. Again, this means g of f of x, which means we plug in f of x into g. So g was the function square root of something, and what are we plugging in? We're plugging in x squared plus 2. And look, we're done. We don't need to reduce that in any way. So that is our g composed with f. And now what's allowed in here? Well, f of x, we're allowed to plug in anything we want. And then, no matter what we plug in for x here, it's certainly going to be a positive value, right? We plug in 0, we get 2. We plug in a negative, we're going to get a positive here, plus 2. Plug in a positive, we get a positive plus 2. So if we plug in 0, we get 2. If we plug in anything that's not 0, we get something above 2. So everything inside this square root symbol here is a positive. And therefore, no matter what we plug in for x, this calculation is allowed. So our domain of g compose f is all real numbers.